From the Oregon State University's Extension Service, you are listening to In the Woods with the Forestry and Natural Resources Program. This podcast brings the forest to listeners by sharing the stories and voices of forest scientists, land managers, and enthusiastic members of the public. Each episode, we will bring you research and science-based information that aims to offer some insight into what we know and are still learning about forest science and management. Stick around to discover a new topic related to forests on each episode.
So I'm excited for this episode. Today's conversation is sure to be a colorful one, and the pun is intended. Today, we're welcoming Dr. Seri Robinson, professor in the Oregon State University College of Forestry's Wood Science and Engineering program. Welcome to the podcast, Seri.
Thanks for having me.
Let's get started with a quick introduction. Seri, you wear a lot of different hats in your professional life. You're a professional wood turner, an author, a science communicator, and it turns out the leading authority in the science of spalting, just to name a few. Clearly, you have a broad range of wood-centered interests spanning art and science. Can you tell us a little bit about the path you took to get to where you are now? What draws you to practice and study art and science in the way that you do?
Yeah, great question. So my undergraduate degree is actually in art and design in woodworking, which is my passion. I've been a woodworker now for 33 years, so my whole life. And then after art school, I wanted more information about the material. I felt like we were taught a lot of design principles. We didn't get a lot of mechanics, which is weird coming from me because I don't actually really like mechanics as a whole, but fundamental mechanics was really important to me to be a woodworker and a wood turner. So then I did a master's and a PhD in forest science, which was wood science under a different name. And I got really involved in spalting. Spalted wood, of course, is where fungi, certain types of decay fungi can grow through and into wood and digest it, and they leave behind these really bright colors. And it's been used in art for hundreds and hundreds of years across many different cultures. And it's very popular in wood turning. It remains very popular in wood turning to this day. And I really liked the colors. And when I needed something to research for my master's, my advisor was like, well, what do you like? And I brought in a piece of spalted wood. And I was like, look, it's really bright. I like the colors. I like what it's doing. And he was like, well, what is that? And I was like, I don't know, spalting. And that's all anyone really knew. It's spalting. It's spalting. Well, what does that mean? I don't know. And it turned out no one had really ever sat and defined it either. So that was really fun because I got to define sort of this area of art, give it a real definition. And then I launched into some deep look at the causal fungi and kind of broadening it out. There had been a little bit of work on zone lines, which are those black lines in wood, but no one had really looked at the pigments. And so, yeah, it's just been a rabbit hole of getting to learn more about a historic art form, getting to use it in my own work as a sculptor. And then it turns out that a lot of that, those fungal secretions, when I'm talking to kids, we call it fungus puke. A lot of that, those secretions have a lot of neat artifacts and things that can be done in like optoelectronics, so solar cells and batteries and things like that. So they have a lot of neat properties that keep me sort of 1 foot in art, 1 foot in science.
Oh, yeah, no, that's fascinating. Truly the intersection of art and science, and the fact that you were able to really blaze trail there on something that hadn't been explored much.
My favorite part of it being in a science program like wood science is the ability to talk about how this whole field of science, this whole field of art, it wouldn't be here without art. And so I think a lot of times scientists get really held up in we've got to take physics and we've got to take chemistry and we've got to take all of these things, but art is the exploration of the unknown as well, just in a slightly different way. And how many times art can lead to new scientific understandings about things that maybe scientists didn't care about before. Because, realistically, who was going to go look at fungus puke and be like, I bet we can make a solar cell out of that.
Exactly. That's a very good point. Not a pathway a lot of people would have thought of, right? No. So it does sound like there's a lot of directions you could have taken your career. What brought you to OSU to work in the wood science department?
It was just a sort of a chance thing. So I was still in my postdoc at the University of Toronto, and my old advisor at Michigan Tech was going to retire. And so they actually built a position for me there, which was going to be a sort of art-sci blend position. And it was really cool. And I was really excited for it. And this position came up, and things hadn't been finalized really at Tech yet. And on a whim, I applied for it because I'm in a wood anatomist position, if you can believe that. I taught wood anatomy, and you have to understand wood anatomy in order to do spalting and wood turning, right? Because it's all wood anatomy, understanding how the fungi move through the wood and how they affect the structure of the wood, affects how you machine the wood, and it affects what kinds of colors they'll produce. So different woods will give you different types of colors from the fungi. So you have to have an inherent understanding of the material. And I really never in my wildest dreams thought I would get this job. I considered myself very underqualified for it, what with art degrees and things like that. But it sounds like the faculty were really excited about the potential to bring in sort of a new direction into wood anatomy. I mean, who could think of art and wood anatomy too, right? But those two things are actually really intrinsically tied together, especially with woodworking and wood turning.
Yeah,
and so
absolutely.
it was a great opportunity.
Yeah, we're talking about it like it's a new thing here, but you've been here long enough that you got promoted to full professor this year. Is that right?
Yeah, just earlier this year. So this is like, geez, I started here January of 2013. So it's been 12 years.
12 years. Okay.
12 years.
All right. Well, you've talked a bit about it already, but tell us some more about spalting and fungal decay. What's happening in the wood when it's becoming spalted, and what are the pigments made of?
I think really we have to start sort of with the concept of spalting, because a lot of people think spalting is the fungi. So it's really important to break out that spalting is the product of the fungi. So if you think about bees, when we talk about honey, we aren't saying bees. If you go to the store to buy honey, you don't buy bees with the hope that they will make honey. You just buy honey, which is the thing they make. And so spalting is the thing that the fungi make.
Okay.
And so that's a really important distinction to have, because there are lots and lots of decay fungi in the world. And not all of them necessarily secrete when they grow. In fact, even the ones that do won't do it without some type of stressor for the most part. So water's limited or there's too much UV, but a lot of the times it's because there's another fungus and they would like to protect their resources. So fungus A is growing happily on a rotting, they're rotting out a log of maple, and it senses another fungus. And there's lots of ways it can react. It can mate, it can avoid, or it can put up a wall, basically, to keep the other fungus at bay. And so, in essence, those secretions they're either, depending upon the type of spalting, a physical or a chemical barrier that's put into the wood, so secreted into the wood, so that another fungus can't grow on the wood and digest it. Because the fungi, they're pretty slow growing, a lot of them, comparatively to like a mold. And they need time to digest the cell wall and break it down so they can get at the glucose. So in order to do that, they need to hold the resource for a decent amount of time. And they need weeks, months, years sometimes to do that. So they can't have other competitors coming in and taking their stuff. So just like humans put fences around our land to keep deer out, or other humans, I suppose, fungi do the same thing. They put up these melanized boundaries called zone lines, or they do chemical warfare. The sneakier ones do chemical warfare, and they'll just turn a whole log green or pink, and that color is antifungal. And a lot of the times that moves ahead of the decay. So you can have brightly colored wood well before decay has really set in, and that's the best place. Now, if you have a log that's been sitting in the woods for 10 years, it's going to be very mushy, and there'll be lots of good spalting in it. The trick with spalting is always you want to find the pieces or make the pieces where the fungi have been so busy battling and preparing that they haven't had time to eat. Because then you have sort of max structural integrity with a lot of color. But the longer you kind of let them go and interact, the more the wood gets digested. In the end, spalted wood is not structural. It's always going to be used for decorative arts. That's why it was used in marquetry and intarsia historically, and that's why it's used in wood turning today. It's a decorative, beautiful thing, not a structural thing. No ladders out of spalted wood, no houses, please. That's a bad idea.
Yeah, very good points there. You are also doing research and writing about wood products in the kitchen in the context of human health and safety. Does spalted wood come with any unique safety considerations, either for the woodworker or the customer?
That's such an interesting question, because I ended up in sort of wood safety research because of spalted wood, because so many people were constantly asking about spalted wood toxicity. There's a big urban legend that spalted wood is dangerous because people are afraid of fungi, they're afraid of mold, right? You always hear like, look out for black mold, get black mold in your bathroom and it's going to come after you and things like that and kill you and your pets or whatever. But fungi are a kingdom, of course, like animals are a kingdom. So the fungi that grow in your bathrooms aren't the ones that grow on wood necessarily and things like that. It's a huge kingdom. And so the analogy I always like to give is, if you get bitten by a spider, you don't kill your neighbor's dog. And that sounds ridiculous, but that's exactly how ridiculous it sounds to any mycologist when you say, aren't spalting fungi dangerous because black mold is dangerous? Like, the kingdom is vast. And so throwing a whole kingdom under the bus because of a few bad actors is pretty rough. So spalted wood is completely food safe, user safe, all of those things. We've done lots of testing on it. We've failed to kill many zebrafish embryos testing the spalting pigments, because you have to remember, again, that it's not the fungi that we care about, it's their products. So we're using their products, not the fungi themselves. But even then, most spalting fungi are used in they're either eaten by humans or used in like traditional medicine. So they've been a part of us for a long time.
Yeah, interesting. So we're talking about kingdoms and fungi battles. This is getting more violent than I thought it might,
It's pretty violent, yeah.
So what about non-spalted wood? I mean, we'll shift subjects here a little bit, but any safety concerns in regards to using wood products that don't have fungal decay?
The whole wood product safety came because when I was talking about kingdoms and wood toxicity and spalting toxicity and things like that, I would always say, listen, people were concerned about the dust from turning spalted wood. I would say, but wood dust itself is toxic. So I don't understand why you're concerned about the fungi when the base material you're working with causes cancer. And that's like really well studied. And no one seems to know that much either. But wood dust is a massive human carcinogen. And we've known this for, 30 years at this stage. But it just it branched into talking more and more about wood anatomy, surprisingly, and wood extractives, which all, of course, wood scientists know very well, and talking about different types of wood and how we use them in daily life, right? Spalted wood people were always asking about in the kitchen in particular, because they wanted to make salad bowls or cooking spoons or cutting boards with a little bit of light spalting, which is fine. And then, so the conversation always went, well, the spalting's fine, but what wood species are you using? Because you know that not all wood species are food safe. And that was a whole, the amount of people who were just completely unprepared, I think, to think that any species of wood would be different than any other one, right? It's like the whole wood is wood. Therefore, all wood is safe is another one of those wild not even kingdom, we're in a much smaller area here. All dicots must be safe is another wild assumption. But as we all know, right, there's a big difference between woods. Purple heart, which is purple, is a very different wood than balsa, which is functionally air. And right. So, what makes purple heart different than balsa wood? A lot of it's extractive. So things that the tree makes in order to murder, right? It's all about murder. This entire podcast is about nature and murder. That's what you should call it, the murder podcast. And you get a lot of listeners. So trees, of course, as you know, right? Preaching to the choir here. Trees make their own protective defenses when they're turning the sapwood into heartwood. They turn their extra sugars over into extractives, and those extractives are meant to kill broadly across many kingdoms, including the animal kingdom, of which we are a part. We're much larger than an insect, but that doesn't mean they don't affect us.
Right.
And so that's gone into a lot of talking and publications about let's really talk about what's in your wood and what should go in a kitchen, because there's a difference between what you use for a breadboard, which doesn't really get wet so much, and extractives tend to move pretty well with water. So if you're just cutting dry foods, you could probably get some sketchier woods versus what you use in a cooking spoon, which goes in boiling water for, say, pasta. And then the pasta absorbs the extractives that are in the boiling water as pasta absorbs the water. And then you're physically eating the extractives that are in the wood. That's a really big difference. So you have to really think about the application of the wood and the species.
Oh, very interesting. Yeah, no, these are things I had not really thought about. But what does, so backing up a little bit, it sounds like the potential impacts are pretty minor, but should I really throw away all of my favorite tropical wood cooking spoons, or can I assume that they're safe because I've never had a reaction to them before? What's the big deal?
I get that question a lot. So I had an allergist explain this to me once, that everyone, if you think about allergies and sensitivities and anaphylaxis and all of those things, they're all related. Like toxicity is one thing, allergies is the other, but they can blend. So if you think about, for everything that you come in contact with, there's a little cup inside you, and everyone's cups are different sizes for different things. Now, I have very bad asthma, and so I have very tiny cups for basically everything that can be inhaled. So me smelling cedar once is enough to drop me on the floor, but maybe you, Scott, have worked with cedar for 20 years and you've been fine. So your cedar cup is a lot bigger than my cedar cup. But so everyone has different exposure limits that they can handle. But the point is, we all have cups, and those cups all have limits. So the more you work with something and the more you expose something, the more you're building up your reaction to it. And you see it a lot if you talk to guys who have worked in cedar shingle mills, for instance, and how they can't be around the smell of cedar at all. They'll have anaphylaxis. People who work with walnut long-term, I mean maybe 10 years, they start to develop pretty bad reactions to walnut. It's one of those things that, depending upon your size of cup, maybe you're not reacting, but you also have to keep in mind the size of your body compared to maybe the body size of a child and the consent of the people coming over. So if you have your favorite, I don't know, bloodwood cooking spoon that you've always made pasta with, and you're serving dinner to a 3-year-old who has a much smaller body and an unknown, cup size, what could the potential effects be there?
That's a really good point. Yeah. And just talking about that in general, my cedar cup, not having used a dust mask or respirator for far too many years, I suppose that cup is nearing full. Yeah.
There's a lot of cups that could be overflown there in the near future.
Wear your breathing protection there, right?
And your skin protection too, like make sure that when you're in the shop, you shower after, because the dust from what you've been working with is on your skin, and your skin produces oils, and those extractives are extracting on your skin and absorbing into you. And that tends to be a pretty big thing too. Your mucous membranes, your nose, your eyes, getting it on your eyelashes and then getting it inside your eyes. These are all ways that slowly you accumulate these problems. And some woods are just like generally toxic. There's a lot of tropical woods that are just toxic to touch, toxic to ingest. Regardless of the size of your cup, you're going to have a reaction. So you have to think about it. In North America, we don't really have that many problematic species, but woodworkers do love a tropical wood. And there's many a breadboard, with inlays of purple heart and bloodwood and walnut and maple all glued up together.
All right.
You just have to, think about the application. What are you going to do? How are you going to do it?
No, very helpful. So while we're at it, are there any other popular wood in the kitchen myths you'd like to address?
One of the biggest things I did this last year was talking about wood finishes on cutting boards. And this is one of those, I feel like everyone in the wood science department kind of inherently understands this. It's a concept so basic that it would be in a wood textbook, right? If you put a finish on wood, it doesn't absorb water as readily, right? We understand this. This is a concept that we all get. And that's the point of finishes, right? Is to keep wood from cycling so much with changes in humidity. But in the kitchen, that's a bad thing, because wood being hygroscopic and constantly equilibrating its water means that as a cutting board, if it's unfinished, if you cut raw chicken on it and you wash it, just rinse it with water, it'll pull that bacteria down into the board and the surface remains clean. And this research, this base cutting board research, has been around for, again, probably 20, 30 years at this point. It's very old and it's very well understood, and there's tons of literature on it. And people still really struggle with understanding that wood as a cutting board or a cooking spoon or in the kitchen should be left unfinished because of those properties, which have been proved over and over again. So because people were struggling with it so much, we just did a quick little finish study. So we used mineral oil and we used linseed oil and we did some unfinished, and we used salmonella and listeria and made tiny little cutting boards and then stamped them on agar plates to see just to show, have a real nice visual representation of how much more bacteria you have with finish. And it was wild.
Oh, really?
Unfinished wood is just the best at moving bacteria away. So it's pretty much always clean, the surface of unfinished wood. And it's pretty much species irrelevant. They all clean. Some clean faster than others. Obviously, ring porous woods, like red oak cleaned the fastest, as you could imagine, with those giant open vessels that go all the way through. Cleaned itself almost immediately, which is funny because common knowledge is that red oak should be avoided for cutting boards because it's so porous. Most of the common woodworker knowledge is avoid porous woods and definitely never use red oak because it's so porous that you'll get bacteria in the board, when in fact that is exactly what you want to happen.
Bacteria in the board, not on the board.
That's right. In the wood, not on the wood, is the name of the game. Yeah. And because someone out there is thinking this while they're listening, they have done tests where they've sliced the boards back open and tried to re-isolate that bacteria, and it is dead. It is not re-isolatable. It is gone. And it doesn't matter, even mineral oil, which is a non-hardening finish, doesn't matter. It also prevented absorption of the bacteria. And in fact, there was significantly more bacteria on the linseed oil boards, which was a hardening finish. And so it blossomed the bacteria.
Interesting. Okay. Yeah, I'm sure that's going to be really fascinating and maybe counterintuitive to a lot of our listeners here. So
there's
for anyone,
a bunch of podcasts on it if people want to hear, because after I published, I got invited to talk a lot about it. So there were a lot of strong feelings about wood finishes out there.
Oh, yeah. I've heard many. So for anyone looking to learn more about your research or interested in supporting your lab, where can we direct listeners for more?
Sure. The lab's base site is northernspalting.com, just like it sounds. My lab, my research is actually crowdsourced. So we don't do much in the way of granting. Most of our funding comes from the global woodworking community, who's very invested in learning more about the materials they work with and how wood can be functionally used, right? Historical spalting or wood in the kitchen. And that's done using Patreon, which, if you're unfamiliar, is a sort of like month-to-month sort of crowdfunding place, right? And so it's Patreon, patreon.com/spalting. And you can subscribe there just to like the lab newsletter and get the updates, or you can, pop some money over to the lab and, feed a grad student.
They get hungry. Yeah.
They do. Oh, it's crazy like that.
And I'm sure people can just go to like Google Scholar as well, look up your name.
Oh yeah, I'm all over Google Scholar. If you put in Robinson and Spalting, you'll keep yourself busy for days.
Perfect. Well, thanks much. Before we wrap up this episode, I have a few more questions for you in what we call the lightning round of In the Woods cast. Now, the first question is always, what is your favorite tree species?
My favorite tree species is sugar maple. So Acer saccharum, because it's a dense wood, right? Dense white wood. So you get maple syrup from it, but also it gets figure like crazy. You can have bird's eye maple, you can have curly maple. A lot of the maple figures happen predominantly in hard maple. So I love that it can distort and get the great different chatoyances, but still be really easy to work with. It spalts great too. And it tastes great. It's a tree for every man.
Perfect. What's a unique tool that you use that helps you with your work?
A unique tool that I use. I mean, my favorite tool, I don't know if it's unique. It's unique to me, is a 3/8 bull gouge. That is my favorite wood turning tool. 3/8 flat-topped bull gouge.
All right.
Great for turning spalted wood.
Wood turners will know exactly what that means. The rest will have to go look it up probably, right?
Yep.
I think you've already answered the third. The question is, what other resources can you share for our listeners that would like to learn more about your research? I think you've listed those already. Any others? Yeah, okay.
There's lots of books. So I've written a couple books on spalting too, and Living with Wood is one about like functional wood anatomy in the home. So there's some, cool. If you're not a web person, there are books.
All right. So, well, Dr. Robinson, thank you so much for spending some time with me today, for sharing your knowledge with our listeners.
Thanks so much for having me. This was a lot of fun.
Absolutely. I learned a ton here. And this concludes another episode of the OSU's Forestry and Natural Resource Extension's In the Woods podcast series. Thanks for listening. Don't forget to subscribe.
The In the Woods podcast is produced by Lauren Grand, Jacob Putney, and Scott Levengood, who are all members of the Oregon State University Forestry and Natural Resources Extension team. Other members of the team who've been involved in the podcast include Carrie Berger, Jason O'Brien, and Stephen Fitzgerald. Episodes are edited and produced by Carrie Cantrell. Music for In the Woods was composed by Jeffrey Heino, and graphic design was created by Christina Freihoff. Funding for In the Woods is provided by Oregon State University Forestry and Natural Resources Extension, the Oregon Forest Resources Institute, and the USDA Renewable Resources Extension Act funding. We hope you enjoyed the episode, and we can't wait to talk to you again next month. Until then, what's in your woods?